be assessing the evidence found on our virtual field trip to come to a conclusion about where life started and the environment from whence it came.
Ancient volcanic rocks in Western Australia have long drawn the attention of scientists for many years. Researchers have been studying this area in an attempt to understand what early life was like 3.48 billion years ago, and to investigate where life may have begun. The region itself is filled with many stromatolites. A good example of this can be seen in the evidence here.
As we have seen, there are two possible niches that the microorganisms have filled. The first is the hydrothermal vents, deep underwater. The second is shallow pools upon early Earth's surface. However, many people are still skeptical about the strength of the evidence.
Here we have Buick locality Site 1. In the sample, we see evidence of rippled sand, indicating a shallow water environment. The shallow water interpretation is made as wave ripples do not form in deep water systems, although don't suggest a lake or lagoon environment. The faint starburst crystals seen here corroborate with the evidence we next identified at Zebra Rock.
Here we have Zebra Rock. The starbursts that are seen in this rock are thought to be salt gypsum. This is crucial in understanding the atmosphere at the time. Gypsum can be formed as a byproduct of sulfur oxidization. In addition, these starbursts show that evaporation took place in the shallow water. This has implications in evidence for life beginning in these shallow primitive pools.
Next, we look at Barite Curl Jokic Site 1. These microbial fossils show complex branching structures where the dark branches contain iron. Modern microbial communities use iron as a source for energy and are known to build branching structures like these.
Another sample from Barite Curl Jokic Site 1 are the ash shards which are found along the hydrothermal vents in the area. These demonstrate high volcanic activity which may have provided organic chemical compounds which microbial mats could have used for nutrients. Both the hydrothermal vents and ash shards demonstrate there was once a volcano. The rapid collapse of the volcano would have released huge amounts of ash, encasing and preserving the microbial life surrounding the area and forming a caldera.
Further evidence of the caldera can be seen in the shallow lakes, as these could have been formed as a result of the volcano collapse. Deep hydrothermal vents contrast with the evidence of shallow pools that are demonstrated by the ripples. Both environments provide strong evidence of the existence of life, but counteract each other in how life may have arisen.
In summary, we've found that Earth, 3.48 billion years ago, had high volcanic activity, with shallow pools and deep hydrothermal vents. We have seen that both the deep hydrothermal vents and the shallow pools had the ability to harbour life, and both show evidence of life arising. However, there is still much controversy as to whether this is actual evidence of the first life on Earth.